And do you want me to, I'll make you a co-host so you can share your screen?
Yes, that would be great.
Okay. Did you get it? There you go.
Okay, can we see my screen?
Yes.
Perfect. And let me pull this up. Okay. So before I get started, I just wanted to introduce myself to everyone. So my name's Janice. I am currently a graduate student at the University of Minnesota. I'm doing a food science program here, and my research is related to alternative formulation. We're looking to reformulate banana and zucchini bread. Well, more specifically, banana and zucchini bread, but my research can apply to any kind of breads with fruit and vegetable inclusion, so any kind of fruits and vegetables. Yeah, I can explain more about my research as I get along with my presentation. But first, I would also like to, acknowledge that my research is funded by the Healthy Food, Healthy Lives Institute, which I'm really grateful for. It's the only reason that my research is possible. I also wanted to give special thanks to all the cottage food producers who have been helping me out with, the recipes, how the cottage food industry is working over here in Minnesota. So also the Cottage Food Producers Association, the Farmers Market Association, and of course, the University of Minnesota Food Science Department, where I'm currently doing my research. So just a little bit of background on my research. I'm focusing on alternative formulation. And like I mentioned earlier, it's baked goods with fruit and vegetable inclusion. We're focusing especially on banana and zucchini because, we love our banana and zucchini bread. We have two of our main goals for my research is to make a healthier recipe. Currently, the Texas recipe calls for about 2¼ cup of sugar per 2 loaves. So we're going to try and see if we can reduce that, make it a little healthier, and for food safety. So right now, in the farmers market, if you want to sell cottage foods, they do have certain requirements, like the bread has to have a water activity of below 0.85, and it's not there right now. So my research would be to see if we can formulate something that would help us accomplish that. So we can start selling, banana and zucchini breads at farmers markets and whatnot. One of the key concepts that we're looking at in my research is water activity. Water activity kind of defines if microorganisms can grow in the bread or not. So if you have a really high water activity, you have a higher chance for microbial growth. So here is my agenda for today. I had two things that I wanted to share with everyone about. So I know I said that my research is focusing on alternative formulations, but we also decided to look into water activity devices. That's because right now, the water activity devices on the market, it's really expensive. So we're gonna see if we can find some alternatives for cottage food producers so that they can measure water activity on their own. And then I'm also going to be talking about, of course, what we're up to with the alternative formulations and whatnot. I just wanted to touch really quickly on what water activity is in case anyone here has not heard the word water activity before. So water activity is related to relative humidity. If you take relative humidity and divide it by 100, that is what water activity is. So if it's a foggy day, it's foggy outside, the relative humidity would be, say, 100%. So you divide that by 100, and the water activity on a foggy day would be 1.0. A comfortable relative humidity would be around 50%, so that's a water activity of 0.5, and the humidity in the Death Valley is 10%, so the water activity in the Death Valley is 0.1. And that's also the atmosphere in a bag of chips. So the water activity of the atmosphere inside the bag of chips would be 0.1. So that would be roughly how water activity works. So first up, we have our water activity devices. So like I was saying earlier, the current devices are they're really expensive. They are more than $7,000. And by current devices, I mean the standard devices used in the food industry to measure water activity for quality control. We did find like a $700 water activity device that kind of works, but it's not established in the food industry, which means that they might not find it very reliable. And for us to, or cottage food producers to send in like a sample of their bread or candy or whatever to get tested and get a value for what the water activity is, it would cost between $15 to $30. It's not a lot, but it eventually adds up. It would also mean that producers can't test, each batch. They can't do quality control, make sure the water activity is the same for each batch. And sending it to a lab also means like a time delay. You have to wait. You have to send it, mail it, or if it's not close to you, and then you have to wait for them to get the results back to you. So there is a real need for cheaper devices that cottage food producers can use on a day-to-day basis. We're looking for something similar to like a pH meter that's easily calibrated, easy to use. So if we have like a cheaper device that producers can use, then you can do your own testing at home. So just to add, I think I did mention this earlier as well. The cottage food law says that for the food to be considered non-potentially hazardous, it has to have either a pH of below 4.6 or a water activity of below 0.85. And that 0.85 is a big factor in like being able to sell the baked goods that we were talking about, like muffins, banana breads, and whatnot. And if we did find a device that worked, producers would also be able to test new recipes at home. So let's say they wanted to say add walnuts or add pecans to their muffin or anything. You can immediately test and see if your recipe fulfills the condition of being below 0.85. So here's what we did for the initial stage of our research. We did purchase 5 different devices to test water activity, and you can kind of see the price range of what we were looking for. We found some in like the $20 to $30 price range, some in the $50, and then there was that one $700 one. And then I did note there as well some of like just some notes about the devices. Like one of them broke when we did excessive testing. Another one took really long to you take a reading and you have to wait really long until you can get the next one. So each device, because it's a cheaper device, it has like a problem of its own. I do have to note though that right now this is just research, and we're not recommending any device at this stage. So we're still making sure we do all the appropriate testing to see if it works or not. So what we found from this initial testing is so this graph looks really complicated, but it's actually really simple. So if you look at the black line, that's where you're supposed to be if your device is very accurate. So if your reading is above the black line, that means that the cheaper device is giving you a reading that's higher than what it's supposed to. And if your reading is below the black line, that means that your reading is lower than what it's supposed to be. So you want to be exactly in the black line. That would mean that the device gives you really accurate reading. So for this first device, for example, you can kind of see the blue line is above the black line. That means that this device specifically gives you readings higher than what it's supposed to be. And we did this for, a few other devices as well. And you can kind of see that none of these cheaper devices are exactly in the black line. They're, at the lower water activities, they are kind of above the black line. And at the higher water activities, it's kind of below the black line. There is, depending on the device, some of them have like a really large deviation. So, you can take a reading, like the first time you take a reading is very different from the second time you take a reading. So that's why we're doing all these testing to see if these devices work or not. So here are our next steps on how we could potentially make these devices work. So our first step would be to develop a correction model. So how the correction model would work is that we would have an Excel spreadsheet, and you can key in the reading that the device gives you, and then the spreadsheet would spit out like a corrected value. So that way, even if the device isn't reading correctly, we would be able to get sort of an actual reading from it. The spreadsheet correction model would also include an error bracket. So because the model is giving you like a predicted corrected value, and there might be some error in the prediction, that's why we need an error bracket, because the prediction might be wrong. So that would be the lowest and the highest number that the predicted number could possibly be. And whatever model that we develop, it would be very device specific. That's because if you use the model for device A would need to correct the value by, say, this much, but then device B would need to correct it by a different value to get the correct, because the correct reading. That's because every device is different. So whatever model we make, it would be very device specific. You can only use the model for whichever device that model is meant for. So we did come up with a draft of the model. It's not fully developed yet, but if you look at the picture with like the blue set, like the blue table on the left, that would be kind of how it works. You would key in what your device is measuring, and then the Excel spreadsheet would spit out its predicted value. And then on the right side of it, you can kind of see we have the error bracket. So the highest value it could possibly be would be like 0.957 for that scenario, and the lowest is 0.945. And the picture on the right, like the table on the right, that's just something we do to come up with the predicted value. The table on the right would essentially means that if we do measurements for what it's actually supposed to be and what the device reads, we need that table to make the table on the left, so that essentially what the table on the right does is we can tailor that to individual devices. So if we come up with that table on the right for each device, we would be able to come up with the table on the left to come up with the predictive values. I guess what I'm trying to say is we can make models for any device that we want, as long as it's a consistent, as long as the device is consistent. So then the second step would be to have training with cottage food producers, so we can have the devices and the models, but if we don't know how to use them, then it's kind of pointless. So we would, once all this is fully developed, we would like to have training with cottage food producers. We would show them how to prep samples, how to use the device, how to use that spreadsheet we were talking about. And I believe the training is tentatively scheduled for March or April. And I think closer to the date, Shelly would have more information for the cottage food producers here who would like to get trained on these water activity devices. So that was it for water activity devices. That's what we've been working on to find the like an alternative for cheaper water activity devices. So next, I'm gonna just briefly run everyone through what I've been working on with the alternative
Shannon,
formulations.
can I interrupt for a second?
Mhm.
You do have a couple of questions in the chat. Do you want me to read them to you, or can you see them?
I can pull them up.
Oh, maybe it's a comment. I've spent hours online trying unsuccessfully. Do you see that?
Yes, I see that. Yeah, you're welcome. We're gonna work on this, and hopefully, we're getting somewhere with it too. So hopefully, we'll have positive results that we can share with everyone during that training session that we're gonna have.
Does water activity change in transport?
It really depends on the atmosphere and the humidity and how you store it, how you cool your bread. It just really depends on the environment. I don't believe it would change much. I wonder if Dr. Ubbink can help me with this one.
Yeah, I think you're already providing an important part of that answer. I must say it depends on the product. There are products which during storage can have a varying water activity. For instance, if you during the staling of bread, which is the recrystallization of starches, that can have an impact on the water activity of a product. So yes, in principle it can happen. It can happen during the shelf life. If it happens during transport, that I would see also as part of the whole supply chain. Basically, the key thing during transport, what can happen, what we often see is that samples heat up enormously. So if you transport something in a truck, things have happened in stores somewhere during transport where in the full sun they can really heat up, and that can have an impact as well on the water activity. So overall, I think if you're a bit careful, the products are not stored for too long of a time. I think these changes are pretty small. However, in the adverse conditions or long storage times, yes, there can be an impact on the water activity. Does that answer the question?
I think so.
Yep. And then, yeah, and because we're in Minnesota as well, if it's in the winter and it's a little colder and you're not heating it up, so maybe the change would be less drastic as well because of the weather. Let's see, the next question is, I would imagine this would be able to help improve shelf life as well. Yes. If you have a water activity where microorganisms are less likely to grow, or their chances of survival is lower, then yes, it would improve shelf life. Let's see. And the most recent question, you mentioned accuracy changes with each sample for some of the tests. I wonder if you test multiple devices from each brand. So we did not test multiple devices from the same brand, just because these are like the cheaper ones. They don't, like, the same brand does not manufacture 5 different devices of under that brand itself. So we only tested one device from each brand. Could there be additional inaccuracies across individual devices from the same maker? Yes. That's because these cheaper devices, they aren't sent to like special labs to accredit like their readings, and that's what these cheaper devices are missing compared to like the $7,000 devices that, you know, they have a team specially allocated to come in like every 6 months, every 1 year to come in and calibrate the device. So these cheaper devices, they don't really have like a customer service team to, you know, attend you. It's a really cheap device. They sell it to you and, you know, they're done. It's not like the really expensive device where, you know, they would come in and check. So yeah, these cheap devices, once they sell it to you, you're kind of on your own, which is why we're seeing how reliable some of these devices are. Yes.
Dennis, may I just add to it? I must say, this is a really crucial point. The idea is also that the ones that are using it, the cottage food producers, will do a simple calibration occasionally. We're looking at various substances that you might have in your supply somewhere, like either salt or sugar, so you can prepare a solution to test the device and then put a corrected value in the spreadsheet. Overall, I would expect that, you know, multiple devices from the same make, that there will be vastly different. So the calibration needs to be carried out on the spot for each device.
Yep. I hope that answered your questions. Does anyone else have any questions before we continue?
No, they just said that's really cool.
Oh, thank you. But yeah, if anyone thinks of any other questions while, you know, we're carrying on with the presentation, we do have some time allocated at the end for questions as well. So if you have any questions, you can, you know, start typing them in the chat, or we have time after this to answer some questions as well. So now we're going to jump into alternative formulations. So the alternative formulations we're doing is because of, you know, the cottage food law. For food to be considered safe, it has to be a pH of below 4.6 or water activity below 0.85. So that's, you know, that's all we've been talking about today. And like we also mentioned earlier, zucchini and banana bread are really popular among cottage food producers. So from the samples that we made in the lab, as of now, the typical water activity for banana bread is around 0.85 to 0.89. The recipes that we use for this banana bread, they are mostly recipes that the local cottage food producers have shared with us. So we're just doing some water activity testing on those. And the typical water activity for zucchini bread, also made in our lab, is around 0.83 to 0.87. So these values they're close enough to 0.85, which means that we should be able to figure this out and, you know, get it under 0.85. And that's what my research is for, to see if we can do that. The picture on the left is just, you know, a bunch of zucchini bread that I made. The picture on the right is a picture of the book of recipes, with recipes all the way from Texas. So they have a zucchini bread recipe in there that says it has a water activity of 0.78, and, you know, that's below 0.85, so that's a good thing. But we've made the recipe and replicated it a few times, and we still have not even gotten close to 0.78. We've, you know, the lowest we've gotten is like 0.84, but we've also, because we replicated it, sometimes it, you know, ends up being 0.86. So this is just a reminder for, you know, all of us that we should get our own recipes tested and our own bread, even if you're, you know, copying off, even if you're making someone else's recipe and, you know, they claim that their recipe is, oh, it's, you know, 0.8, it's below 0.85, so it's a really good recipe. Just remember that, yes, you know, you can make someone else's recipe, but you still need to get what you make tested, and not just base it off of someone else's water activity, because we could be doing something different from, you know, what the, you know, we're doing what the recipe says, but, you know, there may be some steps that are different that make our bread have a high water activity. So if you're not sure, well, even if you are sure, you know, always have it tested. So with the banana bread, we did do some testing with like changing white and brown sugar levels. We did substitute, butter with like vegetable oil and like different kinds of fats. We did like tweak the leavening agent a little bit. So essentially on the right, that picture, we can only make two conclusions from it. One is that the more sugar you put in, the lower the water activity, which is what we're trying to do. We're trying to lower water activity. The more the sugar in the bread, the lower the water activity. But that also kind of defeats the purpose of what we're doing, because we're trying to make a healthier recipe. The second conclusion that we can make is that the blue line that you see is banana bread made with white sugar, and the orange line under it is banana bread made with brown sugar. So because the blue line is above the orange line, all it's telling us is that banana bread made with brown sugar has lower water activity than banana bread made with white sugar. Yep, and I think that covers our key findings from banana bread for now. As we can see, it's still above 0.85, but it's really, really close. So what we're gonna do from here is, we're gonna do more testing. The first thing we're gonna test is we're going to bake a series of banana bread with like 20%, 40%, 60, 80, 100, 120% sugar. What that means is that the 100% sugar is the amount of sugar in the original recipe. So whatever original recipe we're using, we're considering that 100%. So when we say we're going to bake a 20% sugar, we're only going to use 20% of sugar of what was in the original recipe. And the reason we're doing this is because when more sugar is dissolved in the bread, there is more effect on water activity. So what that means is, so just now we were saying that the more sugar you put in, the lower the water activity. But it doesn't matter how much sugar you put in if the sugar is not dissolved in the bread. If it's not dissolved in the bread, it won't lower the water activity. So by not dissolved, I mean, you know how you dissolve sugar in water. So that's what it means by dissolved. It can be dissolved in like in the butter, in the bread, or the oil in the bread, or the eggs in the bread. That's what it means for the sugar to be dissolved. But if it doesn't dissolve, that means it stays as a sugar crystal, meaning it's like the sugar in your pantry, the sugar crystals. So yeah, the sugar has to be dissolved in the bread for us to be able to, make changes to lower the water activity. And we'll be using this technique called X-ray diffraction. X-ray diffraction would let us see how much of the sugar is not dissolved in the bread. So that would be what we're trying to look at with testing the different sugar levels. And then we're also going to test different types of sugar, like high fructose corn syrup, brown sugar, maple syrup, dates. The concept with this is that these different sweeteners have different molecule sizes. So the smaller the molecule, the lower the water activity. So we're going to do some testing with that. And some additional plans that we have is we're going to do an analysis on the ingredients, see where we stand with the water content on the ingredients, and we're going to see if it's possible to further regulate the moisture of the ingredients by dehydrating bananas and zucchini. Yeah, we're just going to see how that turns out. So that we have zucchini bread. We did do some testing on size of zucchini, so whether we grated it with a large hole grater, small, or if we cube the zucchini, if that's going to do anything. The idea with that was to see if how the water kind of leaks out of the zucchini when we put it in the bread, depending on the size of zucchini that's in there. And one of our biggest findings from this is that for the larger size of zucchini, it's too heavy and it will cause the batter to collapse. So you can kind of see that on like the top picture on the right, where you have just like a massive hole underneath like the crust. So it looks nice from outside, but it's actually empty on the inside because, you know, all the batter collapsed. And then we did try, you know, a combination of like vegetable oil, shortening, butter. The recipes with vegetable oil, they are moist, which is what we think, you know, everyone's looking for, you know, moist bread, but it is really oily, so it doesn't feel very healthy. And then we did look into substituting oil with applesauce as well, just because, you know, all over the internet, if you ever look up like how do you make oil-free zucchini bread, that's the first thing that comes up. There's like a lot of recipes that just substitutes vegetable oil with applesauce. So we did do some trials with that as well. And so the texture of the bread was still okay. It was still pretty good, but it increased the water activity. So that kind of defeats the purpose of what we're doing. So yeah, we're making it healthier by taking out the vegetable oil, but it also increased the water activity. So it's making it less safe. So yeah, with that, yeah, the internet has a lot of substitutions for, you know, what you can do to like either take out oil, take out sugar, but just keep in mind that whatever substitutions you make, just to get it tested for food safety purposes, you know, test the water activity to see how that change impacts your recipe. And oh yeah, and we also did just a preliminary test on, you know, what if it would affect like the texture of the bread and the water activity by hand squeezing out the water. So we didn't dehydrate the zucchini or anything. So there's no, like when we squeeze out the water from the zucchini tentatively, there's no significant effect on water activity, but it did change the texture drastically. So you can really tell that it's much drier. And I want to say that, you know, that's because in zucchini bread, most of the moisture comes from the zucchini itself. So just like the banana bread, we're going to do something similar for zucchini bread. We're going to do the same sugar series to see how much sugar is dissolved. And then we're also going to test the different types of sugar and see how that affects our water activity. And same thing, we're going to check our ingredients, and we're going to see what we can achieve with dehydrated ingredients, meaning dehydrated zucchini. So yeah, that is pretty much all I've been working, most of what I've been working on for water activity devices. Yes, there are a lot of cheaper water activity devices out there in the market. They work, but well, most of them work. We just need to come up with like, you know, like the correction model so that we have like a corrected values with them, and to train everyone on how to use them. And with the alternative formulations, we are really close to 0.85. We just need some extra like research on the factors we were talking about, like the sugar dissolving and like the size of the molecules. And with that information, we are hoping that we can just push it a little to get it below 0.85. So we're very close, and so there is that opportunity to reformulate to get within specifications. And yeah, just wanted to make sure that everyone knows that to you know, get your samples tested, not just test your recipe like the first time you make it, and then if it's below 0.85, you keep making it, but you know, also to test it once in a while, just in case there is a variation in you know, your like when you're making the bread that you're not realizing. So this would also help tell you if you're making the same bread every time under 0.85. Yeah, and that is it. If anyone has any questions today, let's see.
There's
the chat.
Yep, there's a couple in the chat.
Have you tried it with other sugars, honey, molasses, etc.? I believe right now molasses is on our list of one of the items that one of the sugars, the sweeteners that we're gonna try. So we have not tried it, but that is in our experimental plan going forward. We should have that. We should have tried it within like the next year or so. Honey, we did not include honey as of now. We had maple syrup on our list, but yeah, we can think of including honey as well. Oh, you're right. Sugar doesn't dissolve in oil or fat. Butter has some water. Yes, that is correct. Overall, do you think the cheaper devices, especially those you tested, are worthwhile for an individual CFP to purchase, assuming calibration and use of error calculations? It is worthwhile to be purchased, but yes, assuming calibration and we use the error calculations correctly, then yes, it would be worth it. Do you have a guess about how long they might last and maintain some general accuracy, at least for recipe development experiments? Right now, we have not done like a shelf life testing on the devices. There were 1 or 2 devices that, you know, after 6 to 8 months of testing, they broke down. But, you know, we use them like every day to take like, you know, 30, 50 readings in like a day or a week or whatever. So we did like take a lot of readings with it, and some of them did break. But there were some that did not break after those extensive testing. How long they might maintain general accuracy, it really depends on the device. Some of these devices can be calibrated at home by the user. So these devices generally would be more accurate than the others because you can calibrate them, but then some others you can't really calibrate them. You can only tell like how far away it is from the actual value, and then we can correct it with the model, but you can't really calibrate it to have the correct reading. So we would have to use the models to correct the reading. What would be, say, 3 first steps to try to reduce water activity without increasing sugar in a recipe? I don't have a first 3 steps for now. I can't think of a step off the top of my head that says that, you know, if you do this step, for sure it would reduce water activity. We are testing like the smaller molecule sweeteners and checking to see like how much sugar is dissolved. But other than that, I was wondering if Dr. Ubbink had any suggestions.
Yeah, I think this is actually the purpose of this project, to really substantiate it. So we formulated a couple of hypotheses, like the molecular weight of the sweetener. The lower the molecular weight, the more effective it will be. So for instance, that's the reason why the brown sugar probably lowers it more effectively than the regular sugar. I think molasses could be a really good one to go for, because very likely molecular weight is even lower than brown sugar. So that's one hypothesis. That partial dehydration is the second hypothesis. And then we have also a third hypothesis, which we're actually testing. So yes, we have some ideas and we're working on it. We're still open for some further ideas. The thing is, also these ideas to some extent came up in conversations with our partners from the Farmers Market Association and the cottage food producers. The thing what we want to ensure is that we test them in a robust manner, so that we really do it scientifically correct. And that means a lot of repetitions, a real experimental plan. So yes, we have some ideas and we hope to get it back to you in the next update, maybe later this year.
Yep.
Maybe still one word on these devices. I must say, one of the things which really we wanted to look at, because there's this whole series of cheaper devices available, and I've been really curious for a while to see, are they any good? So I think we didn't find any testing report on them. There's nothing in the literature. There's nothing also scientifically explored on them. So we're building up that base of knowledge to see, are they any good? I think Janice is working. She's been literally taking hundreds and hundreds of measurements over a period, I think now of about 6 to 8 months. I think that's probably a very first, which will be in the public domain. As soon as we have wrapped it up, we'll be publishing it and distributing it. But there's really nothing available. So I think these questions are all really good. Also, if a device is robust, how long do they keep? Janice broke already a couple of devices, which I think is a good thing here, not a bad thing. It's just because she tested them so extensively. So I think we're getting that much more settled also in the course of this project.
Yep. Thank you, Dr. Ubbink. Let's see. Oh yeah, I also just wanted to add that yeah, some of these steps, like the 3 first steps question, some of these steps, they do reduce water activity, but right now it's not reducing it enough for us to fulfill that 0.85 water activity. Will you be exploring sugar alternatives like monk fruit sweetener? We will think of it, of adding it to our plan. Right now we don't have monk fruit sweetener on it, but that's a really good option. We were focusing on sweeteners that are, I don't want to say more available, but more common to obtain. But yeah, we will definitely consider adding, we will definitely consider looking into a monk fruit sweetener as a sugar alternative. Similar with xylitol and non-sugar sweeteners, we were trying to experiment with more accessible sweeteners. I'm sure you can buy xylitol and other non-sugar sweeteners that are made in the lab, but it might be a little more pricier one, and because we're also we were looking to make recipes that, I don't want to say, more like clean label and healthier. We were trying to make a recipe where, you know how the trends are nowadays, where they're like, oh, we see an ingredient we don't recognize, so it's not clean label or something like that. So yeah, we're just trying to come up with ingredients that won't stump people because, it's made in the lab, or, people consider unhealthy because they don't really know about it. So we're just looking at more general clean label, not clean label, but just more general sweeteners. When I first got my permit, there were some approved recipes. Have those been verified? There are some approved recipes, like the Texas recipes. They were verified by the person who was making them. But like I was talking about earlier, you could follow this recipe, ingredient for ingredient, step by step, but you could still come up with a different product because of, where you're making them, your elevation, because water activity is all based on the environment. So it could be an approved recipe, like the Texas approved recipe, but even if you did follow the recipe, you would still have to get your product tested, because you could, like, I think I'm repeating myself, but if you I guess what I meant is, even if you follow the recipe, there is like a really high chance that you would get a different water activity. Yeah, sorry, I'm just a little jumbled up, so I hope I'm not repeating myself too many times. But yeah, I really like that question.
You're fine, Janice. You're doing great.
Yes.
I think what you're trying to say is that every baker produces, even though you use the same recipe, it will turn out different for each person.
Yeah.
Yes.
We talked about that at that meeting that we were all at, and kind of a standard of practice. It's, just how you do things, your kitchen, ingredients that you're using, all that.
Yes, very well put. Thank you. Let's see. This is absolutely fantastic. I've been wanting information like this for years. Thank you. We'd be happy to, share all this information with everyone. Let's see. I love that. Thank you for explaining the theory. You're welcome. Some of the recipes they are testing are those approved recipes. Yep, we did test those Texas recipes as well. Can you tell us your method of testing? Did you test immediately after taking the item right out of the oven, or wait for it to cool 2 hours, or the next day? Very good question. So technically speaking, you can take the reading, the water activity reading anytime you want. But what I have done is I've waited, so I would wait, 1 or 2 hours for it to cool, and then I put it in a Ziploc bag. And then I wait 12 hours or so for the bread itself to, equilibrate, let all the water move around inside the loaf. And then in like 12 or 24 hours, that's when I take my water activity reading. So that way it's not like wet in one spot because of like the banana, zucchini, and like drier in another spot. So just so that the sample that we cut into to take the reading, it's kind of representative of the whole loaf. So I've been taking readings 12 to 24 hours after it comes out of the oven, just to, let the bread equilibrate a little bit. Yeah, I hope that answered the question. Dr. Ubbink, do you have anything you would like to add?
First of all, I want to add that you're doing really a great job in presenting this work. I just want to, for the audience, so Janice in her master's study, she started a year ago. First semester here, there's a lot of coursework. So she started only in later in spring 22 with her research. And I think she's already generating a lot of output. And I'm really great to see also the feedback from everyone in the room. And I must say, just can thank you, Janice, for all the work you're doing. And I think it's, I'm fascinated by the project and looking forward to be working together also with all of you on these type of approaches.
Thank you. Yeah, so I did include an email on my slide. So that is the email of Morrine Omolo. Dr. Omolo is an extension specialist. She is someone, well, she works with extension, and if you have any, food safety questions about, the cottage food you're producing, if you don't know if you're supposed to test something, any questions related to this, you can always email her and ask. Shelly is a good resource as well. I didn't put Shelly's email on this because I didn't ask for her permission to put it on here, but I'm sure Shelly would answer, help out if you had any questions as well. But yeah.
And Janice, I think you could maybe put your email even in the chat here, because questions also go straight to you. You know a lot about it. You're doing that work.
So yep, that's my email. And yeah, that is all I had to share for today. I don't know if Dr. Ubbink would like to share a little bit about what our food science department's vision is for working with communities.
I'll be very happy to. I'm just still looking at my screen here. If there's anyone who would like to share still something about this work or any general comment before we move on. If not, I'll be happy to say a few things about our Department of Food Science and Nutrition and the engagement with communities and the partnering with communities. It's really a crucial thing. It's where we also have a long-standing tradition in a number of areas. One of them is food safety. I'll say a few words about that in a couple of minutes. The other part is actually in via Extension and the Center for Family Development with Trish Olson is Associate Dean. We have a couple of faculty members in my department, Marla Rijks, Craig Hassel. In January, we had an extension staff member starting, Abby Gold, who are working with these communities in and around the Twin Cities, mainly in the area of nutrition for communities, so community nutrition. But what we see coming up, and I'm personally really fascinated by that, is also that interest by communities to produce foods. The cottage food producers, of course, are a prime example of them, but you see it happening more. Startups, family-based businesses with all kinds of different types of foods. And as a Department of Food Science and Nutrition, we want to be relevant and we want to partner with those communities and those producers. Food science historically has been working mainly with the industry, mainly the large industry, and we have a lot of that in and around the Twin Cities and in Minnesota. But we definitely want to shift and include also those who work with food in different settings. I've worked in the food industry for a long time, but also have a culinary background a little bit. So I know that's an area in the food service setting, which is really irrelevant, which we try to do things. And then also, you as the local, the smaller producers, that's a very relevant community for us to be interacting with, to understand your problems, to understand your challenges, your opportunities, to get your input. I'm very impressed with all the things that I'm reading here in the chat. And it's something which makes us a more rounded program in food science. So we're not only working with the larger industry, but we're working across the board from kitchens to small facilities, to startups, to larger companies, to ingredient companies, et cetera, et cetera, et cetera. I think that's going to be very relevant for us. How we see the future? We're in a transition with food science and nutrition. We have had, a number of retirements of staff and faculty. We're actually hiring. We had 3 staff members onboarding in summer. We're now 3 professors coming in, 1 in nutrition and 2 in food science. We still have 2 open searches for new professors. So we're renewing that department. And we're reflecting upon also a bit our future strategy, and community engagement is a really key one. And not only in nutrition, but also bringing that into the space of, producing foods and selling foods and ensuring the food safety. So we're on it, and I'm also, as a department head, I'm very open for any input you might have, any ideas you might have, any connections for us that are relevant, because this is really part of our future. My role is a little bit of a dual one. Most of my time I'm heading this department. I'm also a professor in this department, and so here I'm the project manager or the PI on the Healthy Food, Healthy Lives project. And there's also my personal interest as a researcher to get to know the issues and the challenges and opportunities that you're faced with. And I'm personally really fascinated by the work we're doing with these small devices. Answers also questions for me. And let's say now exploring these zucchini and banana breads, see what's already in the field from the established recipes and then the methods you're using, and discussing with the local bakers. I must say I'm also learning a lot. So I think this also for me, it's a really worthwhile journey, and getting to know one another and partnering in this field. I think I should leave it at that. I'm open for any questions or any comments from your side.
Can you see the chat, Professor?
Yeah. I see there's a comment. It's so good to know that the U of M recognizes the importance of who we are and are involved in helping to feed the population. Yes, absolutely. I must say, I think in nutrition it's already a longer standing awareness and acknowledgement, and very active in working with the diverse constituent stakeholders and communities. One of the things I really hope to see changing, and I must say it's getting momentum, is that food science starts to really reach out to all producers. So from kitchens to small producers to the larger to the we're relevant. They're all relevant partners to us. I see things changing also very gradually. It's very interesting, because I'm very interested in this field since a long time. It was just a couple of months ago, the international business journal, The Economist, you might have heard of it. They actually had an article about the cottage food law in the United States. Now, if The Economist start paying attention to it, it means that something's really shifting, because normally they pay attention to the larger industry, the global trends, the global state of the economy and politics, etc. So suddenly, it's not too long ago, I think 2 months ago or so, they had suddenly an article about cottage food producers and the cottage food law. And I thought it was really fascinating. I sent it here to the dean of my college, says, Brian Boer, Dr. Boer, who is also interested in this, says, something is changing here in a direction which I think is very promising. There start to be very much more that engagement across the board with all our producers and manufacturers.
Dr. Ubbink, this is
Yes.
Jennifer Caravio. In one of the meetings that we had, we were talking about the use of the water activity meters and that type of thing, and your studying and the information and all the data you guys have gathered is absolutely amazing. And I don't know, maybe this is putting the cart before the horse a little bit, but I know one of the things we really talked about, and that's why they're putting together a training program, is the importance of good SOPs, standards of practices, when using these water activity meters. And while I recognize once this study is complete and done and we're able to use use the water activity meters, hopefully end goal, I'm wondering if you might want to take the time to explain to us just really how important that procedural and following the right steps is important for accuracy, because that's what you're trying to do with your study. And then once we have results, we're going to have to follow through and do the same.
Yes, exactly. This is really crucial. So SOPs are very high up. Actually, we also in the lab, as soon as we have a method for whatever project we work on, we're trying to solidify that into an SOP. Also here, part of what we want to do is to actually come up with these SOPs, also with a lot of visual information in there. So that's not only a whole, document with only text, but really with pictures and so on, illustrating how to do it, and also trying to build in some robustness to some testing at some steps. If you do this, you should end up with about this value, for instance. So we're working on it. Janice mentioned that we will be setting up a workshop to actually explore a little bit how these devices go. That's, of course, for you to get to know them. I must say this workshop serves a dual purpose. It's also for us to understand how you're working and getting your input. And we can use that also, and relating that back to the SOPs. It helps us to understand how you're working with, what's feasible, what's not feasible, and we can try to then loop that in the way we formulate these operating procedures to make sure they're as realistic as possible. So I think there could even be some iteration there. But this workshop where we're planning, that's definitely also intended for us to understand better where you're coming from and what you can and what you cannot do. Any further comments or questions?
Thank you very much,
Thank you.
Professor. Amy and Cindy, did you want to say anything? I apologize. We would have had a whole segment with you, but we didn't know that you guys had taken over before the conference.
This is Cindy. I wouldn't say we've taken over. We're on day 8 of our new position. So I don't know I can't speak for Amy. I feel like I've just barely got my feet under my body. It's been really exciting, and I'm just super excited to start getting to work on all the cool stuff that's going on. And this project just sounds really relevant and really exciting. So yeah. Amy, do you want to?
Yeah, I guess whatever for Janice, however myself and Cindy can help you with next steps in this research and getting that information out, and with trainings, we're obviously here to help you as well. So
Yes.
Absolutely. Thank you. Yeah.
Let me just add to that, Cindy, Amy are so new, we haven't even met internally. So we're definitely looking forward to that. Things move fast, which is good. Maybe just also what I see, and what's also for our department really key in the, we'll be looking very much in the next 2 years or so to see how can we bring in also some, maybe an extension specialist or a professor in food safety and food safety microbiology in this wider area, so we can really internally build up a whole structure of from educators and specialists and faculty, and bringing also students in for projects, so that we get a a good strategy in place and then implement it, and then we can really work effectively with our partners and constituents.
Great. Sounds great.
This is just really exciting. Yay. Because we get so many questions as an association on water activity, and how you explained water activity, Janice, was amazing.
Thank you.
Thank you. It's
I got that from Dr. Ubbink. He taught me that.
awesome.
Yes, Jennifer, in any case, anything comes up with water activity. Actually, water activity is one of my research areas. I usually don't apply it to food safety, so I'm learning a lot about food safety as well now. I'm using it for no shelf life and stability and in processing and so on. I think also in the future, and also with Cindy and Amy, if there's any programming and materials are needed or an input, or it can show up and give them maybe a little introduction to water activity, I'll be happy to do so.
Yeah, I also just wanted to add that, yeah, you know, we focus on water activity, and my research right now, we're looking at banana and zucchini bread. But if anyone has, you know, any questions, it can be, you know, canned food, candies, you know, any kind of food that you're making, spices. Our educators and extension and the university and department, the extension, we would be really happy to answer any questions. So it doesn't just have to be water activity and like breads. We would love to help with, you know, anything, everything food related, cottage food related. So it doesn't just have to be bread. And you have all of our emails. Any questions, processing, you know, SOPs, just anything. We're here to answer questions, not just water activity and bread.
Okay.
Great. Thank you very much. So if there are any more questions?
Here's a comment from Gail. I don't have my glasses on.
So
Just basically a clear description of water activity would be really helpful for vendors, especially tier 1 CFPs that don't take tier 2 training. I finally made my own infographic for our cottage food handbook. And that is so true. We do have tier 1 training, but this is pH, water activity. Both of those are something, and Amy and Cindy, I know moving forward, maybe we can all get together, and Professor Ubbink and Janice and whoever else is interested, and see if we can encourage a little more training on that. Maybe as an association, we could do a few more webinars throughout the year on it. So, and vary them in time, so that maybe people who work full time during the day, I know you primarily work during the day, but sometimes evening is helpful, or a Saturday morning or something. So that is a big one that we get a lot. And we do have most of our cottage food, registered cottage food producers are tier 1. So yeah. And then there's something else.
Joy wants to know if they're testing pumpkin things yet, but it's just banana and zucchini that's being focused on at the moment. All right.
And then I'm sitting here thinking maybe taking it, you know, outside of this at some point, maybe doing some of this and applying it to dog treats and doing specialized training on it, that now that that's part of the law. I think that would be really good as well, because, for example, sweet potatoes, you can dehydrate those and sell them, but how many people know that you should actually flash them first in hot water before you do it, and then cool them so that you kill microorganisms on the outside of the potato that was in the ground? Just little things like that.
Good idea. Okay.
I know I love my dog.
We know. All right. We thank you guys very much for the information and for being here with us.